Did you know that the Millennium Prize Problems are the 7 well-known complex mathematical problems that are toughest in the world, and these have been selected by the Clay Mathematics Institute in 2000. One of the problems have been solved, and there are 6 remaining problems, and each of these problems will fetch you a prize money of US dollars, of $1 million prize for the first correct solution to each problem. So these are the 6 problems till date. It has not been solved. So the idea in this video is, can we use ChatGPT? Can you use other large language models, open source or closed source, any models, to solve these 6 problems and earn $6 million? Let's see the technology that we have now, and let's try to analyze whether it would be possible right now to solve these problems using the LLMs that are available with us. So as we know ChatGPT. It is an amazing tool. We know Google Bard. We have other open source large language models, but we know that these large language models are very good at language interpretation. They're very good. They can very well analyze the text data. They can understand our emotions. You ask them to write a letter, a poem, or defy a logic, it can do that. But typically for mathematical questions, these large language models face hindrance and face difficulties in giving us a correct answer. Now, to solve these issues, to get a level ahead for the mathematical problems, the authors in this paper have devised a new algorithm, or defined a new large language model that can bridge the gap. Of course, it is not 100% perfect, but the level of improvements that they have shown in this paper, it's quite commendable, and we hope to see something better and better results in the future. Ultimately, a day will come when we have solved the Millennium Prize Problems. Now, this is based on fine-tuning large language models and open source large language models, especially the Llama 2. So they have fine-tuned the Llama 2 open source large language models. The name of the method, or the name of the LLM, the fine-tuned model they have given, is the MetaMath. So MetaMath, bootstrap your own mathematical questions for large language models. This is not the only paper that have attempted this. There were, of course, different papers that have attempted to bridge the gap, to improve the understanding of mathematical reasoning, because for the mathematical reasoning we cannot have a linear sort of reasoning. We need to have a comprehensive understanding, just like how we as human beings think. So they have used 2 benchmarks. One is known as GSM8K, which is a grade school math 8K questions, and other is a math benchmark for mathematical reasoning, and they have demonstrated a model performance of 66% on GSM8K and 19% on math. So math benchmark is a little bit tougher. Now they have exceeded the state-of-the-art models, which is 11% and 8%. So for 11%, the performance increased to 66%. That is quite a lot of improvement. And from 8.7%, the performance was increased to 19.4%, and that is again twice, about 2.3 times the performance increase. Now MetaMath, they have tested on 3 different parameter versions: 7 billion, 13 billion, and 70 billion. So this MetaMath 70 billion achieves an accuracy of 82.3% on GSM8K, and is slightly better than GPT 3.5 Turbo. So what this method actually is that it is trying to bootstrap the question. So for example, if we have a meta question, for example, James buy 5 packets of beef that are 4 pounds each. The price of beef is $5.5 per pound. How much did he pay? The answer is he bought 5 times 4, which is 20 pounds of beef. So he paid 20 times $5.2, which is $110. Now the question bootstrapping is the method. In this method, we rephrase the question. So we ask, what is the total amount that James paid when he purchased 5 packs of beef, each weighing 4 pounds at a price of $5.5 per pound? And then we get the answer. There is this self-verification question in which we make an unknown variable. So we say James buy X packs of beefs that are 4 pounds each. The price of beef is $5.5 per pound. The answer was he paid $110. What is the value of the unknown variable X? So we rephrase the question. We self-verify the question and in the form of an unknown variable in this method. And then we have the 4-bar, which is forward, backward. So we have a different paper on forward backward reasoning, but this is 4-bar is forward backward reasoning in large language models for verification. So in the forward backward, we say that James buys X packs of beefs that are 4 pounds each. The price of beef is $5.5 per pound. How much did he pay? If we know the answer to the above question is 110, what is the value of the unknown variable? So these are different types of question bootstrapping, and the answer argument is changed to James buys 5 packs of beefs that are 4 pounds each. So he buys a total of 5 times 4, 20 pounds of beef. The price of beef is $5.5 per pound. So he pays 20 times 5.5, which is 110. And this is the MetaMathQA. This is the dataset that they have modeled. So the MetaMathQA dataset is formed using the question bootstrapping strategy, and the questions are bootstrapped into these 3 forms. The first is rephrasing the question, second is a self-verification question, and the other is the forward-backward verification question. So this is the new dataset, and using that dataset, the Llama 2 open source LLM is fine-tuned to get the MetaMath large language models. So this is the simple strategy that they have used to train MetaMath, and we can see that the blue color indicates MetaMath. We can see the test accuracy for different parameters, 7 billion, 13 billion, and 70 billion. The test accuracy is more for 70 billion, of course, and the test accuracy is again about 26% here in the 7 billion parameter. And this one of the papers which have tried to bootstrap the method. We can try other methods to bootstrap this, but this is I would say a simple step forward for improving the mathematical abilities of the large language models. And of course, this is not a complete, or this is not done. We need more and more papers, we need more and more technologies and innovations to improve the mathematical ability. So that is from this paper. Now, if we try to answer the underlying question that we have at the start of this video, is that are we ready to answer the 6 millennial prize questions? I think we are not, but we are way ahead than we were in last year, and we are moving forward, and ultimately someday, very soon, we will see these problems are being solved by just 1 or 2 person, because the person would have figured out, the person would have used large language models or such technology to figure out the solutions to all these problems. So I think that there will not be 6 different persons, working on these 6 projects, but there will be 1 or 2 person who will be working on a technology that will answer all these questions and any other mathematical problems that comes ahead. So having said that, I would like to end this video. Subscribe to my channel if you like this content. Hit that like button and share the content with your friends and families. This is Prompt Engineer signing off. I'll meet you in the next video. Thank you.